Okay, one more question here to really get at the idea of the difference between speed and velocity. Um, you're in this race, and you can walk 4 kilometers north, and then 3 kilometers north, and 4 kilometers east, 20 degrees south along this cleared path. On the cleared path, you can walk a little bit faster, 4.8 kilometers per hour. Or you can try and cut straight through the woods. You know that cutting through the woods, you'll be able to only travel at 3 kilometers per hour. If you go off the path, you have to go a little bit slower. So what we're going to check out in this question, is it better to go around and stay on the path, or is it better to try and cut through and get there directly? So here's your path, 3 kilometers north, and then east 20 degrees south. So like that. So there you go, you can see you have to follow that path if you stay on the path. Or we can imagine the direct route here is just from point A to point B. And so you can see you're trying to get directly through there. If you think about that, then we can view this as delta D1, or your initial displacement, and this as delta D2, your secondary displacement, and then this will be delta D total, or your total displacement if you had gone around. I'm going to work at finding the direct path here first, and then I will use my two speeds to figure out which one is the better route. So first of all, I've got this east 20 degrees south thing. I don't have to do any work with delta D1 because it's all straight north, and so I don't have to divide it into components. But delta D2 has an angle in it, and so I have to divide it into components. This is the adjacent, my delta D2E. So that's going to be 4 kilometers cos 20. 4 cos 20, 3.76. This one, my delta D, that's a delta by the way, it doesn't really look like one. Delta D2 south is going to be 4 kilometers sine 20 for sine 20, which is 1.37 kilometers. I'm not going to put the negative because it's in the south here. I'll put it in when I'm putting it in the chart. So I'm declaring north and east as my positive directions. My delta D1 is 3 kilometers straight north, which means it has no east-west component. My delta D2, these are all vectors, is negative 1.37 kilometers in the north-south direction and 3.76 kilometers in the east-west direction. Remembering that my total displacement is just equal to the sum of the individual displacements. I can directly add these things. 3 plus a negative 1.37, or 3 minus 1.37, works out to 1.63. And obviously 0 plus 3.76 is just 3.76 kilometers. To recombine, I should put the larger thing first to be polite, then the shorter thing. 3.76 kilometers, 1.63 kilometers. So to answer the question here, remember I'm just trying to figure out who's going to get there first, or which way is the faster way. It's not actually asking me for a velocity or anything like that, so I don't have to worry about the direction. I'm just interested in the magnitude of the hypotenuse here. Hypotenuse is equal to the square root of 3.76 squared kilometers, plus 1.63 kilometers squared. That should be in brackets probably. Anyways, that works out to 4.1 kilometers. So if you go directly, the displacement the magnitude of the displacement, is 4.1 kilometers. I think we can see if you go the long way, if you go on the path 4 then 3, your distance traveled, no arrow here, is going to be 7 kilometers. 4 plus 3. So let's put both of those in an equation. Let's just section this off from the last question. Let's put those both in an equation. This one we'll call the path equation, this one we'll call the woods equation, and see what the time is for each one, and then we'll sort out which way we should go. So for velocity, our displacement divided by our time, if we cut through the woods, our maximum velocity is 3 kilometers per hour. So 3.0 kilometers per hour equals 4.1 kilometers divided by time. Should be clear at this point. If you have a variable on the bottom, multiply both sides by the variable. Divide both sides by 3.0 kilometers per hour. And t works out to be here 1.37 hours. Alternatively, if we go on the path, now I can travel at a speed of 4.8 kilometers an hour. My speed is 7 kilometers t, so multiply both sides by t, divide both sides by 4.8, and t is equal to 1.46 hours. So what we can see is if we cut through the woods, it's going to take a little bit less time than taking the path. So based on this example, we would suggest that you should cut straight through the woods. That is, of course, assuming that cutting through the woods is not cheating. And if it is cheating, of course you must take the path, because we can't condone cheating. So that's it, and we'll get back on with videos on projectiles.